Yeah, thank you very much for the introduction. This work is part of my PhD thesis, or which I did in my PhD. So if you are interested in more fancy password stuff, just look at my PhD thesis. As already said, I will give a talk about the wide diversity of password requirements and how we can cope with this situation. When we're creating passwords today for our online accounts at Facebook, Amazon, and so on, the passwords need to fulfill two requirements. First, the passwords must be attack resistant, which means the passwords must be randomly generated and provide a security level of at least 128-bit so that the passwords can even not be guessed in an offline brute force attack. The second requirement is that the passwords must comply with the individual password requirements of the services. Otherwise, the services simply reject the passwords. The best thing that we have for generating passwords is a password generator. I personally use KeePass, and here in the screenshot you can see the configuration screen of KeePass, where you can configure which character sets can be used or how long the password should be. I think this is common for all the existing password generators out there. The problem when you use such a password generator is the fixed password compositioning rules, which leads to passwords that does not comply to the second requirement. As you will see later in my talk, one of the problems is that a lot of services does not provide you any information about the password requirements. For example, here on this website, it is complaining that your password does not meet the complexity requirements, but it actually does not provide you any information what these requirements are. This website states in the first requirement the password length you can use, in the second requirement the character sets you can use, and in the third one, yeah, there is this bullet 7. I don't know which this one is. Beside this problem, services also use different requirements. So you need to configure the password generator for all the different services manually. There's also another problem. The services use different terminologies to describe the password requirements. And sometimes this is really hard to understand. For example, this website says use at least 8 characters long with 0 non-alphanumeric symbols. So I think this can be described much easier. Or this website says you should use single byte letters and numbers. I don't know what this is, or at least I don't know how to configure which character set is used when I enter my characters. There's also some other tricky website where here you can see at the first glance you say, yeah, cool, I can use a really strong password and everything looks fine. And if you re-enter the password, you will figure out that you can actually use just the first part of the password, because there's a different length for the re-enter password field. So using such a password generator in practice is really tricky. But this does not only apply to KeePass. Here you see an analysis of 15 password generators. Some of them are websites, some of them are part of an application. In the second column you see the default password length, and in the third one the default character sets. L stands for letters, N for numbers, SP for special characters, and S for space. When you compute the security level that results from these passwords, you see a lot of them does not actually provide passwords that I would consider as secure. And the biggest problem here when you look at the acceptance rate of these passwords, so how many services out there would actually accept such passwords that are generated by these password generators, you see that, nearly half of them produce passwords that are not accepted by less than 10% of the services. So when you ever ask yourself why nobody is using a password manager, a password generator, just look at this table. So this is really hard to use this in practice. So generating passwords that fulfill the second and the first and the second requirement is still a challenge. In my talk today, I will show you a solution to automatically generate such attack-resistant and valid passwords, and the only thing you need to do is to provide the URL of the service to generate such a password. My talk consists of 3 parts. First, I will show you a study on study on password requirements. Then I will show you my solution, and finally I will show you a practical evaluation of the solution. Let's start with the study on password requirements. Before I will show you the results, let me explain how I collected password requirements. For me, it was important to have an understanding of the password requirements on a global scale. So it was not sufficient for me to just look at Facebook, Amazon, and so on. So I really needed the password requirements of a large amount of services. Doing this manually, of course, it's not applicable. So I developed an application, the password requirements crawler, which is capable of doing this automatically. The crawler takes as input the URL of a service and then automatically extracts the password requirements from the website. The crawler consists of two parts. First, the password requirements finder, which is looking for the sign-up form on a website. Why the sign-up form? Because this is the most likely place where services specify their password requirements. When the finder finds the sign-up form, it downloads the source code and hands it over to the second component, the password requirements extractor. The extractor extracts password requirements from the text that is included in this website and also from the source code itself, as you can see here from the maximum length attribute of this input field. As I already mentioned, the biggest problem is that the services use different terminologies to describe the password requirements. To cope with this problem, I used machine learning technologies and built the extractor based on the Apache UEMA framework, which allows you, or which gives you a couple of tools to develop such NLP applications. When you build such a tool that automatically doing stuff or automatically processing text, there's always the question, does it work accurately? And to do or to verify that the tool works fine, I manually extracted the password requirements of 250 websites and also let the crawler extract the same, or let the crawler to extract the requirements from the same 250 websites. And the evaluation shows that the tool works really fine and extracts the password correctly for more than 90% of the websites. After knowing that this tool works fine, I used it to analyze more than 3 million websites. A lot of them were not available, or at least not available from Germany. A lot of them were static websites where you cannot create a user account. Also, some of the websites were websites like banking websites where you can log in, but you cannot create an account and can choose a password. So all of these websites I was not interested. And finally, I was able to collect the password requirements for more than 185,000 services. Let's take a look at the results. So these services allows you to create an account and to choose a password. So I would expect that they have some sort of password requirements. Actually, just 57,000 services, so around about 30%, actually specify some requirements on the website. Some services say the password length, other services say the character sets you can use. Just 4,000 services actually specify all the requirements that you need to create a valid password, which means the website tells you how long the password should be and which character sets you can use. So when you create a password in practice, the biggest problem is that you have no idea how the password should look like. And the only thing you can do is try and error. When we take a look at which password requirements are specified, we see that the vast majority of services specify the password length. Just 1/3 specify the character sets you can use, and just 15%, around about 15%, specify requirements like, so the occurrences of characters, so requirements like you should use at least one letter or use one special character. When we take a look at the character sets, we can see that the services usually specify letters and numbers. And you see here in the third row the percentage with respect to all the services that specify character sets. And the fourth column shows you the percentage with respect to all these 57,000 services. As you can see, special characters are not widely used outside, and yeah, when we talk about spaces, this is really just a couple of services specify spaces. What's pretty interesting here is that, yeah, more services specify numbers than letters. I guess the reason why this is that services accept letters by default and only state additional characters when they actually, when users can actually use them. But of course, I don't know. When we take a look at the minimum and the maximum occurrences of character sets, we can see here the minimum occurrences, so phrases like please use more than one letter or something like this, or one number. You can also see here that when you encounter such a requirement, it's usually please use more than one number. There are a couple of services that use special, or you let enforce a special character, but we didn't find any services that requires you to use a space. When we take a look at the maximum occurrences, so requirements like do not use more than 5 numbers or something like this, this is not really used out there, so there are just a couple of services having such requirements on the websites. When we take a look at the password length, we can see that around about 40% specify a minimum password length, around about 70% specify a maximum password length, and when you thought about a password length should be some sort of a range between a minimum and a maximum, you would actually find this just on 20% of the websites. What is also interesting here is that more services specify a maximum password length than a minimum password length. I would expect the other way around, so saying that a service actually enforce some security by saying, okay, I specify a minimum password length, but actually it seems that the service is more concerned about implementation issues, that you might enter longer passwords than their application can process or something like this. Here you see the distribution of the minimum password length. As you can see, we actually found a couple of services that allows password with 1 or 2 characters. The vast majority accept or enforce passwords with 6 characters, and we also found some security-conscious services with a minimum password length of 9 and 10 characters. When you take a look at the maximum password length, you see here a much wider diversity. Some of the services does not allow you passwords with more than 8 characters. On the other hand, there are services that allow you passwords with 2 billion characters. This is a password of 2 gigabytes. I didn't try it yet, but I guess if you tried to create an account with 2 gigabytes, you would crash the server. But give it a try. When you take a look at the whole picture, it seems a little bit arbitrary, but there are actually patterns in there. One pattern is that the password size has something to do, or is the multiple of 10. So you can see here 10, then we have 20, here 30, 40, 50, and here 100 again. So it seems to be that the admins of this website obviously like these numbers. The second characteristic is that the password length has something to do with the power of 2. So you see here 8, 16, 32, 64, 128, and 1024. The third characteristic is that the password length has something to do with the numeric size of what you can store in some data types. So 15 is the maximum size you can store in a half byte. 255 is the maximum size you can store in a byte. And this 2 billion is the maximum size of an integer. I don't know if this gives some indication that the services store the size of your passwords, and because they store the passwords in plain text, I have no idea. Because when I would hash passwords, I wouldn't mind about the length of the passwords. But I don't know. Overall, I found more than 1,400 different password requirement sets. I also analyzed the security level of that results from these password requirements. You see here the password, the security level and the acceptance rate of such a security level. Here, this red line shows you the minimum security level, so which is enforced by the services. This is mainly a result from the minimum password length. Here, this green line shows you the maximum security level, which is allowed by the services, which is mainly driven by the maximum password length. This graph shows you three serious security issues. First, around 60% of the service does not enforce any security level at all. So you can say they don't mind about the password security. The second one is that weak passwords, so passwords with around about 50-bit security level, are actually accepted by nearly all the services. When you're talking about passwords with 50-bit security level, they can brute forced today in a single second, even if they are randomly generated. And the third, or the worst fact here, is if you take a look here, is that attack-resistant passwords can only be used at 78% of the services. So if you are a security-conscious user and you want to use secure passwords for all your internet accounts, this is actually not possible for more than 20% of the services. So far with respect to the study of the password requirements, you see the most problems are that the services use different password requirements and also different terminology to describe the password requirements. And the second, which is maybe the most problem, that 70% of the services does not provide any requirements at all. Let's come to the second part, the solution to cope with this situation. The solution I developed consists of two parts. One, a uniform description of password requirements to cope with the different descriptions of the requirements that are used, the different requirements that are used by the service, and optimal fallback password compositioning rule to generate passwords when we don't know the requirements of the services. Let me explain you the first part in detail. So I developed a uniform description for password requirements, which allows you to create a password requirements description, so a PRD for a service. In this PRD, you can specify the different requirements of a service in a uniform way. Let me show you an example. So this is the PRD for PayPal. As you can see, it's an XML document which specifies at the beginning the character sets you can use for PayPal or for passwords at PayPal. As you can see here, you can use letters, numbers, and special characters at PayPal. The PRD also specifies additional requirements like that you should use at least one number and one special character for passwords at PayPal. And most important, the PRD also specify the minimum and the maximum password character, minimum and maximum password length of passwords for PayPal. Using or having such PRDs, you can build an application that takes these configuration files into account and then automatically generates you a valid password for this. You might raise the question that having these PRDs for a service is pretty nice, but who should generate these PRDs for this thousands of services out there? As I told you in the beginning, I built this crawler which actually can do this for us. With this crawler, we can, on the one hand, we can create these PRDs, but we can also keep these PRDs up to date because we never know when the services actually change their password requirements, and also we cannot keep track of this. So far, I have a database of PRDs for more than 185,000 services. So with these PRDs, we can cope with the problem that the services use different requirements. But as I said, the bigger problem is that we don't know the requirements of the services. So to cope with this, I developed this optimal fallback password compositioning rule. And the objective of this rule is to generate attack-resistant passwords with the best possible acceptance rate. The rule that I developed says use letters and numbers and 22 characters. This provides you with passwords with a security level of 130 bits, so attack-resistant passwords, and an acceptance rate of 76.6%. Let me explain you how I developed this rule. So my problem, of course, was that I don't know the requirements of the services that don't state them on the website. So my assumption was that they have some sort, or they might have the same requirements as the services that provide them on the website. So I developed this rule of, or based on the password requirements I have of this 57,000 services. In the first step, I analyzed all the services, what are the character sets or combination of character sets they would accept. And here, as you can see, letters and numbers are accepted by the majority of the services. Then I computed how many character sets, or how many characters I need to create passwords with a security level of 128 bits. And these are 22 characters. In the third step, I analyzed all the services, how many accept such passwords. As you can see here in this graph, the security level with respect to the password length. So this is here the green line, and of course when you have longer passwords, your security level goes up. The red line shows you the acceptance level of such a security level. You can see here it increases at the beginning, and we have here a peak at 8 characters. So passwords with letters and numbers, and 8 characters are accepted by the majority of the services. But of course, you have passwords with around about 50-bit security, which are not secure. When we take a look at 22 characters, you can see here we have passwords with 130-bit security and an acceptance rate of 76.6%. In the fourth step, I evaluated my assumption from the beginning that the services that don't state requirements on their website nearly have the same requirements as the services that provide the requirements on the website. I did this by simply creating a password with letter and numbers and 22 characters and tested on 100 random services that don't provide any requirements on the website. And it turns out that even 80% of these websites accept such a password. So this is even a little bit better than the estimated 76.6%. So far for my solution to cope with this problem. Let's come to the third part, the practical evaluation. As we all know, the biggest problem is weak user-chosen passwords. And even if the user chooses them themselves, or as you have seen, using a password generator, as some of them produce, not really secure passwords. So when you remember here this graph at the middle of my talk with respect to the security level, we know from a lot of research that user-chosen passwords are usually a little bit better than the minimum security level that are enforced by the services. My objective was to solve this problem by automatically generating passwords that are attack resistant and valid and comply to the password requirements of the services. And my solution consists of these password requirements descriptions, this database of PRDs for more than 185,000 services, and the optimal fallback password compositioning rule. And with my solution, you get secure passwords, attack-resistant passwords when this is allowed or when we don't know the password requirements of the service. And if the services does not allow that, you get at least the best possible passwords. So in any cases, you have the best possible passwords, and the only thing you need to do is provide the URL of the service. I also implement the solution to have a practical evaluation. And as you can see here, this is a screenshot of the Android application. And as you can see, the only thing you need to do is enter the URL of a service, for example, Amazon.com, and the password generator automatically provides you a valid password for this service. It's also available as a web application if you want to try it, but keep in mind this is experimental code, so just take a look at it, but don't use it in practice. We have also developed a KeyPass extension where you can use these features in KeyPass. So if you remember here this screenshot from the beginning, where you need to manually configure KeyPass to cope with these password requirements. And for example, if you want to generate a valid password for PayPal, you need to keep in mind all these different password requirements. Some of them are actually don't actually state on the website. You really need to find them in the source code. So don't be confused if you don't see all these requirements actually on the website of PayPal. So doing this, of course, is not really usable, and one reason why people don't use password generators. But with the extension that I built, it's pretty simple. So the only thing you do here is you enter the URL, and in the background, the PRD for PayPal is downloaded from the server. It configures the internal KeyPass generator and then provides you a valid password. When you also keep in mind the table here from the beginning, where I showed you that a lot of password generators does not generate secure passwords, and also passwords that are not accepted by the services. With using my optimal password compositioning rule, you see that a lot of these password generators would create more secure passwords and passwords that are accepted by more services. So let's come to the conclusion. As I showed you, generating passwords that fulfill the first and the second requirements is still a challenge. And in my talk, I showed you a solution to automatically generate valid passwords, and the only thing you need to do is to provide the URL of the service. And that concludes my talk.